Now let's start a new concept, a new topic in relative velocity. In this video, we want to actually introduce the concept, introduction to the concept of relative velocity, which is the next concept after we have taken our time to understand a lot of things around vectors. The first vector that we'll be meeting is velocity, which we'll be running through a lot in most of the physics things that we'll be doing, especially in mechanics. So it's very important to understand this particular concept, the relative velocity. So velocity, we said, is the displacement, right, in a particular displacement over within a particular time period. That's what velocity is about. So down, but then what does relative velocity mean? Whenever they say relative, right, something relative, not your family relative, right? When they say something is relative to something, relative, so you say A relative to A is like A compared to B. So A relative to B. So if I say A relative to B, you just say A compared to B, or A as compared to as seen by B, or anything like that. A as seen by B, or A with reference to B, something like that. So relatively, right? So when we are talking about relative velocity, it's just the velocity between two or more objects, right? Especially these two objects are usually moving. For example, the cars that we are seeing here, right? This car and another car behind this in are all two cars, and then they are moving. Each of them is having velocity. So if you are talking about relative velocity, is the comparing the velocity of this guy and this guy, right? If let's actually go to the blank board. So let's say this is car A, right? Let me say car A, and then this is car B. Let me just do this one as B. And let's say this one is moving like this, right? With a velocity, let's say VA, and this one is also moving like this with a velocity, let's say VB. So the velocity of this guy is A and then this guy is VB. If we're talking about relative velocity, is uh, if someone is in this car A, right, and then how would this person that is in car A will be seeing, how fast would they be seeing the car B moving? If someone is in car B, right, if someone is in car B, how would that person be seeing car A moving? We also have this experience where when we are sitting in our trotro and cars, there are other cars that pass by us. Some they want to try to overtake us, or tag of war on the road, right? Yeah, it's funny. Especially when the car is moving in the opposite direction, the car just passes by our side. Then we hear the loud sound as if they are very fast, moving very, very fast, especially when they are moving into the opposite direction and we are moving in our forward direction, and they are coming the opposite direction. And when they, by the time, the moment they pass us, then we see them moving very, very fast. But if you are all moving in the same direction, one is trying to overtake the other, right? That's something like relative velocity. So if you're in your current car and another car is trying to bypass you, let's say you are in this car, and then there was a car that was at the back, and then it increases velocity in order to bypass you on the road, right? If you are someone in this car, if you are here in this car, right? How will you be seeing? How will you be seeing someone in this car moving? By what velocity will you be seeing them moving? Okay, the two of you are moving. But if someone is let's say this is the road, right? The two of you are moving, one person is overtaking, and there is someone that's on the side of the road that's standing here. Right? This person will be seeing the two of you moving very fast, very, very fast with a very great speed. This person is standing. But as for you guys, you that is in this car, you'll be seeing this person moving with a relatively smaller velocity, like not that fast, but they try to overtake you, right? If you are in this car, let's say you are in this car and you are bypassing this second car. When you are the one bypassing the car, you'll be thinking that these people rather are moving slowly. Okay, so this kind of um seeing the velocity of one moving body compared to yourself or compared to another body is what relative velocity is concerned with, right? If we are all in a car, we are all moving, right? We are moving at the same velocity. I'll be thinking the person that is in car A, since if you're moving with the same velocity, the person that is in car A, this is car A, this is car B. The person that is in car A will be seeing car B as if they are not even moving at all. Someone that is in car B will be seeing someone in car A as if they are not moving at all, because they are all moving with the same velocity. That's too far. Let's even look in the same car with you. Someone that is sitting beside you, right? you'll be thinking the person is not moving because all of you are moving with the same velocity within the same car. So the relative velocity between the two of you is just zero because you'll be seeing that person as not even moving, and that person also be seen as not even moving. But if it is someone that is beside that is standing by the roadside, the person will be seeing you guys in the car moving very fast. So the relative velocity compared to yourself in the car is different from the relative velocity that the person that is standing outside will be seeing you guys. That's what relative velocity is concerned with, right? How the moving one moving body, right, moves a reference to another. That's basically that. So what is relative velocity if you want to do it formally? Relative velocity is the velocity of a moving body. Usually, just a body can be moving or not moving, but usually it's the velocity of a moving body compared to another body that is considered to be at rest. So we consider even if they are moving, the two of them are moving this and like this, right? Let's say A and let it B, right? One person has to become the stationary. We have to assume. So we are considering or we are assuming, even though in reality the two of them are moving, right? We are going to assume that this guy is, if this guy was stationary and this guy is moving, what's the velocity of this guy compared to the B? So B is stationary and then the A is the one we consider moving. So in reality, the two of them are moving. But if you want to actually measure relative velocity, you need to actually assume that one of them is stationary and the other one is moving. The best way of seeing that is that you consider yourself in this car, right? And the other one is overtaking you. Even though the two of you are moving, but then you that is in this car, you'll be seeing this velocity moving. This car will be moving with a velocity that is a bit higher than yours. But someone that is beside the road will be seeing you guys moving with very high speed, right? So the relative velocity between that person of that person compared to you guys is very large, but the one between you and A and B like is very small because you are also moving, right? That one also accounts. So this guy you be seeing it moving slower than how the person beside outside will be seeing it. So relative velocity is the velocity of a moving body compared to another considered to be at rest. We consider it to be at rest. Doesn't mean that it necessarily has to be at rest, but we just consider it to be we assume it to be at rest. So if you were in this car, if you were in this car, we will also assume that the car A is stationary and car B is moving. The one that we consider stationary is what we call the reference point or the point of reference or the reference, simple term, reference point, or considered to be at rest, right? Yeah. So reference point, or we can also call it observer. We can also call it the observer. Okay. So you can say a moving body compared to another, or it can be like observer, right? This one, let me just put it here, or an observer considered to be at rest. So reference that observer is called the reference point or the observer. Yeah, let me see over here, right? So always, right? Always in relative velocity, even though the bodies are moving, we need to actually assume that one of them is stationary and the other one is not stationary. So this is the basic thing that relative velocity is concerned with. We are going to look at cases, a lot of cases where we'll be seeing them bodies, the two of them moving in the same direction. So if A is moving here, B is also moving there, or A is moving like this, and B is moving like this, so A is moving like B. So they are moving in opposite direction, or or you can even see them moving in. So this guy moving in this angle, this guy is also moving in this angle, right? Or this guy is moving in this angle, and another is moving in this angle. How do we find the relative velocity between these two? So, but we are going to take it one by one, right? So solving cases. So these are parallel; they never meet, but these ones they meet. And when they are inclined, right, there will be an angle somewhere. If you extend it, right, there will be an angle between them somewhere. All these things will come together to play a role, and they will be using some concepts called the um, sine rule and parallelogram law and a triangle law of vector addition and all that all will come back from the previous playlist that you have learned before starting this one. Kindly take your time to watch the playlist on vectors right? There are many videos that you can skip to the one that you want to understand before you come here. And I advise you that the prerequisite for this particular concept playlist is understanding the cosine rule, sine rule, and how to add vectors, because we'll be working more with vectors now. See you in the next session.